In this video, we're going to look at special methods that we can put inside our classes to allow us to compare and to get a printable representation of an object. In the previous two videos, we looked at this rectangle class that we can use to create objects that represent a rectangle. Let's trace through this client program to see what happens. So we start by having a global stack frame for the program as a whole. And you can see we have our three global variables, R1, R2, R3, and R1 and R2 are assigned references to two different rectangle objects, both of which have the same dimensions. Because you can see when I construct them, I'm using the same dimensions, 40 for the width, 75 for the height. And because I'm calling the constructor twice, I get two distinct rectangles, each of which have those dimensions. Then I come to this line of code, and you can see that I'm not calling the constructor a third time here. Rather, I'm saying take what's in R1 and assign a copy of that value to R3. And because what's in R1 is a reference, I'm going to be getting a copy of that reference. And so both R1 and R3 refer to the same object. Okay, now I use the equals equals operator to compare R1 and R2, and I'm going to take whatever Boolean value I get from that comparison and print it. So we're comparing what is in the variables themselves, and in this case, because R1 holds the memory address of this rectangle object and R2 holds the memory address of this rectangle object, I'm essentially comparing those two memory addresses. And because they are not the same, what I end up getting here is false. The comparison gives me false. But when I compare R1 with R3, because they are both referring to the same rectangle object, I'm comparing the same memory address to itself. And so I am going to get true here. So by default, when you use the equals equals operator, you compare the memory addresses of the objects, not what's inside them. And so if we want to compare what's inside the objects, we need to implement our own version of that equals equals operator. And the way that we do it is by defining a method called underscore underscore EQ underscore underscore. And again, if we don't do this, the default version is just going to compare the memory addresses. So here's what that method might look like in the context of the rectangle class. You have to give it this name. You have to have a self parameter and then some second parameter. I'm calling it other. And then what's going to happen is when you use the equals equals operator with rectangle objects, the rectangle object that comes to the left of the equals equals will get assigned to self, right? That reference will get assigned to self, and then the reference in the variable on the right hand side will get assigned to other. And then we're going to execute that method, and you can see what we're doing is checking to see if the two widths are equal. So in this case, it's R1.width because self is R1, equals equals R2.width because other is R2, and R1.height equals R2.height. So if both dimensions match, then we are going to return true here. Otherwise, we're going to return false. So this allows us to compare what's inside the objects rather than just comparing their memory addresses. Another special method that we typically include when we define a new class is one called underscore underscore REPR underscore underscore. And this allows us to get a string representation of objects of our class. And this gets called on our behalf when we evaluate an object from the shell. So we don't actually have to explicitly call this method, just like we didn't explicitly call the underscore underscore EQ method. It's going to get called for us whenever we evaluate the object. It's also going to get called if we try to use the str function on an object of this class. And it'll also get called when we print an object of this class. Now here again, if we don't implement our own version of this method, we get a default version, but it isn't typically very helpful. So for example, let's say I have a rectangle object that I construct and I assign its reference to R2. If I then evaluate R2, I'm going to see something that looks like this. And you can see it's not terribly helpful. It doesn't give me any useful information about the object. So what I'm going to do instead is implement my own REPR. It only takes a self parameter, and that allows me to access what's inside the object. And then I need to construct and return a string. It can be whatever string I want, but it has to be a string that can then be used in these contexts that we discussed. And in this case, what I'm doing is I'm taking the width of the rectangle and turning it into a string so that I can then concatenate this string, which is just a space followed by an X followed by a space, and then I also concatenate the string version of the height of the rectangle. And it's important to note that this method does not do any printing itself. It just constructs a string and returns it. But if I have my rectangle object, when I now go to print it, I am going to see something useful because I'm going to see the string that was created by this REPR method. And you can see in this case it's the width of the rectangle, which is 50, followed by this string, space x space, followed by the height. And so we get the dimensions, which is a useful thing to see when you print the rectangle. And this method also will get called when we just evaluate the object from the shell.